Hi, this is Alex from devstories.eu. PySpark Fundamentals, episode 19 of 21. Saving a massive dataset as a CSV is the easiest thing in the world, and it is also one of the most destructive things you can do to your data lake's performance. You pay for more storage, you pay for more compute, and every downstream query crawls. The fix is in how you handle load and behold storage formats, and why how you save your data matters just as much as how you transform it. PySpark uses a unified interface for reading and writing data across dozens of storage systems. You call the read or write attribute on your Spork session or data frame, specify a format, provide a chain of options, and point it to a file path. It is a predictable pattern, but the options you choose dictate how much work your cluster has to do later. Let us start with the human-readable formats, CSV and JSON. These are row-based formats. When you read a CSV, Spark parses the data line by line. You often need to chain specific options to make sense of the text. For instance, you might chain an option to tell Spark the file has a header, another option to set a custom delimiter like a pipe or a tob, and a third option to define exactly what a null value looks like, perhaps passing a specific string so Spark correctly maps it to an empty value instead of treating it as literal text. JSON is slightly better because it handles nested structures natively, but it repeats the schema keys for every single record, massively inflating the file size. Both formats force Spark to read the entire row from disk, even if your query only asks for a single column. This is where columnar formats like Parquet and ORC come in. Pay attention to this bit. Analytical queries rarely need every column in a wide table. They usually need specific columns across millions of rows to run aggregations. Parquet and ORC store data organized by column, not by row. If you query 3 columns out of 100, Spark only reads the chunks of the file containing those 3 columns. It skips the rest entirely, cutting disk input and output to a fraction of what a CSV requires. Because data of the same type is stored together, columnar formats also compress beautifully. A directory of JSON files might shrink by 70% or more when converted to Parquet. They also embed the exact schema and data types in the file metadata, meaning Spark doesn't have to guess or infer types on load. When you're ready to write this data back out, you have to manage state at the destination. By default, if you try to write to a path where data already exists, Spark throws an error to prevent accidental data loss. You control this using the mode method before triggering the save. If you pass the string overwrite, Spark deletes the existing data at the target path and replaces it with your current data frame. If you pass append, Spark simply adds your new part files to the existing directory. There's also an ignore mode, which silently does nothing if the directory is already populated. Writing clean, typed columnar data today saves your cluster hours of wasted processing time tomorrow. If you want to help keep these episodes coming, you can support the show by searching for devstories.eu on Patreon. Thanks for spending a few minutes with me. Until next time, take it easy.